Welcome to this explainer. If you've ever felt like math is just a bunch of abstract rules completely disconnected from reality, well, get ready to completely flip that perspective. Today we're going to explore how numbers and data are actually the very foundation of how we understand the universe and navigate our everyday lives. Let's dive in. We've got a seriously fascinating journey mapped out for us today. We're going to cover the power of quantitative reasoning, the dawn of mathematics, classical math and beyond, the shift from the Islamic era to the Renaissance, the scientific revolution, and finally, the alphabet of math. Let's kick things off with Section 1, the power of quantitative reasoning, and how it helps us make sense of the world. So, I want you to really ask yourself, why do we actually need math in the real world? Honestly, it's not just about passing a test or memorizing rigid formulas on a chalkboard. It is fundamentally about solving real-world problems. Think about it. Whether you're budgeting to buy a house, analyzing market trends for a startup business, or just trying to figure out if that sensational news headline is actually backed by facts, you are using math. And that brings us to a crucial takeaway. Quantitative reasoning is basically the essential skill set required to draw meaningful conclusions, identify patterns, and make informed decisions based on numerical data. It literally gives us the power to construct persuasive arguments and navigate our highly data-driven world with total confidence. This is exactly why institutions, like the Allama Iqbal Open University, highlighted in our source material, are making quantitative reasoning a compulsory focus across all disciplines. It's what lets us tackle theoretical questions with hard evidence, proving that numbers aren't just abstract. They're actually the most practical tools we have for navigating our daily lives. Moving right along to Section 2, the dawn of mathematics, and how counting was basically a tool for survival. You see, math was born out of sheer necessity. We can go all the way back a massive 20,000 years to the Ishango bone, found in the Congo in sub-Saharan Africa. Early humans were using these tally marks to perhaps track lunar cycles or even keep a record of prime numbers. Fast forward an incredibly long time to 3000 BCE, and ancient scribes in Mesopotamia are using clay tablets. Then by 1650 BCE, we've got the Egyptian rind papyrus dealing with fractions. These definitely weren't abstract exercises. These were vital life-or-death tools for agriculture, trade, and sheer survival. It's so cool to see how two ancient powerhouses approached problem-solving completely differently, yet both laid critical foundations for us. Take the Babylonians. They used a base 60 system. And incredibly, that is exactly why we still have 60 seconds in a minute and 360 degrees in a circle today, thousands of years later. They even used a zero placeholder, though not quite a true place value system. On the flip side, the Egyptians developed a decimal-based system linked to the fractal geometry you can see in their stunning architecture, although they relied heavily on unique symbols for powers of 10 instead of place value. All right, let's jump into Section 3, classical math and beyond, focusing on logic and engineering. We see a massive philosophical shift during the classical era. The Greeks obsessed over the theoretical why, while the Romans cared all about the practical how. The Greeks, who were influenced by Babylon and Egypt, brought us deductive logic. Think of guys like Pythagoras and Thales. They were all about drawing conclusions from axioms and rigorous proofs. The Romans, on the other hand, were the ultimate engineers and builders. They didn't really focus on abstract theories. They applied math pragmatically to build massive aqueducts, calculate taxes, and even invent the odometer just to measure the exact distances traveled by their marching armies. How wild is that? Meanwhile, over in Asia, brilliant minds were making massive leaps of their own. In China, scholars miraculously preserved mathematical knowledge. Texts like the 9 chapters on mathematical art survived the infamous book burnings in 212 BC to teach surveying, geometry, and business. At the exact same time, India was quite literally changing the world. From the precise geometric layouts of the Indus Valley to the Sulba Sutras, Indian mathematicians laid incredible groundwork. But you know their most revolutionary contribution? The formalization of the decimal system, and crucially, the concept of zero. An absolute breakthrough that fundamentally transformed how humans calculate forever. Which brings us to Section 4, the Islamic era to the Renaissance, also known as the Great Synthesis. During the Golden Age, Islamic scholars were the ultimate bridge builders. They masterfully synthesized global knowledge, taking Greek logic and Indian numerals and just pushing them to the next level. Al-Khwarizmi, recognized today as the father of algebra, not only gave us systematic algebraic rules, but also helped introduce those incredibly useful Hindu-Arabic numerals to the West.
This seamlessly passed the torch over to Renaissance Europe, where reckoning schools popped up to teach merchants the math they desperately needed for booming global commerce. And as explorers rapidly took to the seas, trigonometry transitioned from an abstract concept into an absolute necessity for mapmaking and worldwide navigation.
Next up is Section 5, the Scientific Revolution, where we really start expanding the boundaries. Over the course of 4 centuries, visionaries totally transformed math from a tool for commerce into the very language of reality itself. In the 17th century, heavyweights like Galileo, Kepler, Newton, and Leibniz developed calculus, which finally allowed us to understand motion and planetary orbits. The 18th century saw Euler pushing the limits of celestial mechanics. Then, in the 19th century, George Boole established Boolean algebra. He probably had no idea that his abstract logic would one day power literally every computer on Earth. And finally, in the 20th century, minds like Alan Turing and Kurt Gödel laid the theoretical foundations for the digital age, and frankly, for the very device you are using to watch this explainer right now.
And that leads us to our final section, number 6, the alphabet of math, and how we actually build our number system. So we build our toolkit step by step. Step 1, we start with the very first natural numbers. Those are the positive counting numbers from 1 to infinity that those early humans were carving onto the Ashengo bone. Step 2, we add 0. That seemingly simple little addition creates the set of whole numbers, which was a massive conceptual leap that made advanced mathematics even possible. Now we step into negative territory. Imagine 0 acting as the origin point. Integers include that 0, the positive numbers stretching infinitely to the right, and the negative numbers stretching infinitely to the left. This finally allowed us to mathematically represent concepts like debt, temperature drops, or backward movement. It's a foundational component for almost all operations in algebra.
Like nested dolls, we expand our number universe even further. We go beyond whole integers to rational numbers, which is any number that can be expressed as a crisp fraction or ratio. But hey, the universe is messy, right? So we also have irrational numbers, like pi, which are infinite, non-repeating decimals that just can't be perfectly captured as a simple fraction. Combine the rational and irrational, and you get the master set, real numbers. And finally, when you need to solve equations with no real roots, we step into complex numbers, which combine real and imaginary parts. These are absolutely essential today for advanced physics, engineering, and really understanding things like electromagnetism. So now that you understand the epic history and the underlying structure of the numbers all around us, from the ancient tallies in the Congo to the complex logic powering our digital world, you've got the context and the tools to think clearly. The only question left is, how will you use this superpower today? Whether it is analyzing a financial budget, understanding risk, or simply making a more informed, data-driven decision, the power is entirely yours. Thanks so much for joining me on this explainer. Keep questioning and keep calculating.